So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have here these 20 JAMB repeated questions to answer on the topic chemical combinations. So guys, this video will be all about the mole concept and Avogadro's number. So guys, in short, stay till the end of this video. And also, if at any point you feel you want to answer any question before we provide the answer, you can always pause this video and try out to see if you can answer the question even before we provide the answer thereafter. So guys, let's start with the first question here. It says, how many atoms are there in 1 mole of hydrogen gas? So we are given the Avogadro's number or Avogadro's constant to be 6.02 times 10 to the power of 23. So guys, let's quickly zoom into our workspace and solve this together. So the question says, how many atoms are there in 1 mole of hydrogen gas? So guys, hydrogen gas is H2. So this shows that in 1 mole of hydrogen gas, there are 2 atoms of hydrogen. So this 1 mole of hydrogen gas translates to 2 atoms of hydrogen. So guys, if there are 2 atoms of hydrogen here in 1 mole of this hydrogen gas, it means that, so we are going to multiply these two atoms of hydrogen times the Avogadro's constant, which is 6.02 times 10 to the power of 23. So guys, if we try to calculate this, let's simply bring up our calculator here. So let's go ahead and check out the answer to this. 2 times 6.02, and that's 12.04. So guys, this is 12.04 times 10 to the power of 23. So if we bring this point over here to make it 1.204, this will be times 10 to the power of, or increase this power, and that's 24. So guys, with this, I'll have 1.2 times 10 to the power of 24. So guys, the answer to this question here is option A, and that's 1.2 times 10 to the power of 24. So guys, that's it for this question. Let's quickly wipe this and check out the next question. So the next question here is question number 2. It says, what is the molar mass of water? So guys, let's also zoom into our workspace here, and then let's solve for the molar mass of water. So we know that water is H2O. So in order to get the molar mass of water, we are going to get the atomic mass of hydrogen times 2. So 2 times 1, or 1 times 2. Since hydrogen is 1, then times 2 here. Then we are going to add it to the atomic mass of oxygen, and that's 16. So when we add this 2 plus 16, and that's 18. So this will be 18 grams per mole, and that's the molar mass of hydrogen. So guys, the answer to this question here again is option A. So we'll wipe this, and then we'll go ahead and check out the next question, guys. That's question number 3. The question says, a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molar mass of the compound is 180, find the molecular formula. So guys, here we're going to also zoom into our workspace here, and then we're going to solve for this together. So we have a compound having 40% carbon. So we have 40% carbon, and then we have 6.7% hydrogen. Then we have 53.3% oxygen, 53.3% oxygen. So having this in this way, the question says if the molar mass of the compound is 108, find the molecular formula. So guys, here first of all we are going to find the empirical formula for this. So given the reactant mass here, so remember that the first thing we need to do is the reactant mass over the molar mass for each of these elements. So let's go ahead and check that out. So we're going to rule some lines here. So we're going to call this column carbon, and then call this hydrogen, and then call this oxygen. So having this, first of all, we are concerned with knowing the reactant mass here. So guys, we'll use these percentages here as the reactant mass. So this will be the reactant mass. So the reactant mass for this will be 40, this will be 6.7, and this will be 53.3. And then we'll go ahead and check for the molar mass. So guys, the molar mass of carbon here is 12, like we know. Then the molar mass of hydrogen is actually 1, as we already know too. And then that of oxygen is 16. So now we know the reactant mass, we know the molar mass. We can now go ahead and do reactant mass over molar mass in each case. So reactant mass over molar mass. So let's demarcate this. So 40 over 12 here, 40 over 12 will be 3.3. So 6.7 over 1 will be 6.7. So 53.3 over 16, that's 3.3 as well here. So we'll divide by the smallest ratio. So let's go ahead and demarcate this as well. So we divide here by the smallest ratio. So we know that the smallest here is 3.3. So when we divide this by 3.3, we'll have 1. And then when we divide this by 3.3, 6.7 over 3.3. So this is 2.03. and that's approximately 2. So for this, 3.3 over 3.3 is 1. So guys, this is in the ratio 1:2:1 here. So guys, this translates that C will be 1, H will be 2, and O will be 1, which entails that this is CH2O. So let's go ahead and wipe these other parts, the table parts. And so guys, at this point, we've arrived at something for the empirical formula. So we want to use this to get the molecular formula. We already have the empirical formula to be CH2O. So guys, since we already have the empirical formula, in order to get the molecular formula, we need to recall that if we're given the molar mass of the compound to be 180, we're simply going to say the molar mass of this CH2O with sub n here is equal to the molar mass given to us in this equation. So guys, if we calculate for this, C is 12 plus H2, that's 2, that's 14 plus 16, so 14 plus 16 is 30. So this will be 30 N will be the molar mass given to us in the question. So that's 180 here. So if 30 N is 180, then N is going to be 180 over 30. So guys, that's, let's calculate this here. 180 over 30, that's 6 guys. So N is equal to 6. So this means that this formula, this molecular formula, will be such that CH2O will have 6 here. So which means so let's write this down here, which means that we have C6H12O6. So guys, this is actually the molecular formula for this question. So guys, that's option C guys, and that's the correct answer to this question. Option C here is the correct answer. So you're wiping this, and then let's go ahead and check out the next question. That's question number 4. It says, a sample contains 3 moles of nitrogen gas. What is the mass of the sample? So guys, this is just simple. We're going to zoom into our workspace here. We have 3 moles of nitrogen gas. So nitrogen gas is N2. So this is N2. And then we have 3 moles of this. So 3 moles of this is this. So the question says, what is the mass of the sample? So guys, since we have 3 moles of this substance, first of all, we have to know the molar mass of this nitrogen gas before we can solve further. So nitrogen gas is actually 2 times 14. So nitrogen has an atomic mass of 14. Then since we have 2, that's 2 times 14. So guys, that's 28 here, but that's in gram per mole. So since we've gotten the atomic mass of nitrogen gas, and that's 28 gram per mole, so this means that each mole of this substance has a 28 grams. So if 1 mole of nitrogen or nitrogen gas has 28 grams, then 3 moles will have x grams. So when we cross this here, we're going to have x to be 28 times 3 over 1. So 28 times 3 here, guys, is 84. So that's 84 grams. So guys, the answer to this question is option B here, and that's 84 grams. So guys, we are simply going to wipe this off, and then let's consider the next question, and that's question number 5. So guys, the question says the Avogadro's number equals A 6.20 times 10 to the power of 2, B 6.20 times 10 to the power of 23, C 6.23 times 10 to the power of 2, D 6.02 times 10 to the power of 23. So guys, the Avogadro's number, like we all know already, is 6.02 times 10 to the power of 23. So let's quickly go ahead and check out the next question here. That's question number 6. It says, what is the mass in grams of 500 ml of ethanol? So we are given the density of ethanol to be 0.789 gram per ml. So guys, let's quickly zoom into our workspace and solve this together. So this will be very simple. Since we are given the density already, 0.789, so the density is 0.789 gram per ml. So guys, each time you are given anything in this way and you have the units to be 1 unit expressed over the other, you can just simply slide out the units in this way. I'll show you what to do. So you're going to say 0.789 grams here contains 1 ml. So guys, at any point where you have any concentration this way or any units that is 1 unit over the other, you can just simply space it out this way. So this, when you have something per something, it means that for each of the first value you have here, you have 1 value of the second. So guys, that's what we just expressed here now. So for each 0.789 grams, you have 1 ml. So guys, the next thing is to write down the corresponding units down here and here. So guys, from the question here, the units we have corresponding to either this or this is the 500 ml that we have here, and that's corresponding to this part. So we are going to write 500 ml. So what we are saying here is that if there is 1 ml in 0.789, so how many grams now will contain 500 ml? So we are going to have these as x, and then normally, as we always do, we'll cross this. So guys, x will have to be 0.789 grams times 500 ml over 1 mil. So let's go ahead and use our calculator here. 0.789 grams times 500 mil, and that's 394.5 grams. So guys, X here is equal to 394.5 grams. So guys, that's the answer to this question, and over here that's option A, guys, and that's it for this question. So we're going to wipe this, and then we're going to check out the next question, guys. That's question number 7 here, and the question says, what volume of 0.25 mole per dm cube sodium trioxocarbonate 4 solution would give 13.25 grams of sodium trioxocarbonate 4 on evaporation to dryness? So we're given the molar mass of sodium trioxocarbonate 4 to be 106 grams per mole. Alright, so let's quickly zoom into our workspace and solve this together. So first of all, we need to understand that the number of moles of the sodium trioxocarbonate 4 solution will also be the number of moles of the dry one. So in that case, in order for us to get the number of moles for this residue, we are going to actually do reactant mass over molar mass. That will give us the number of moles. So let's always remember that number of moles is equal to reactant mass over molar mass. So guys, in this question here, the reactant mass for the one evaporated to dryness is actually 13.25 grams. Now the molar mass of sodium trioxocarbonate for here as given to us is 106 gram per mole. So guys, it means that the number of moles here will be, let's solve this together, 13.25 divided by 106, that's 0.125 moles. So guys, now that we've gotten 0.125 moles here, we already know that the number of moles for this dry mass of sodium trioxocarbonate 4 is still the number of moles for this initial solution of sodium trioxocarbonate 4. So we are going to say that here we are given 0.25 moles per dm cube of the sodium trioxocarbonate 4, and we want to find the volume of this 0.25 moles per dm cube of sodium trioxocarbonate 4 that will give this mass. So guys, in this situation, what we are going to do is, just like I told you earlier on, 0.25 moles per dm cube can be expressed as 0.25 mole to contain 1 dm cube. So guys, that's what this means. In 0.25 moles, there is 1 dm cube. So guys, the next thing is for us to impute this here. So you already know that since this is number of moles, it's not going to be here, rather it's going to be here. So this will be 0.125 moles. So if we have this, we're just simply going to cross this here. So this is X, because this is what we are now looking for, the volume here. So at this point, guys, we are just going to have X to be equal to, so multiply this, 0.125 times 1 over 0.25 So let's go ahead and point our calculator. So this is this divided by 0.25, and guys, this is 0.5 dm cube. So guys, that's the answer to this question. And since all the options given to us here are in cm cube, so this is what we are going to do. Let's just simply wipe here and get some space to do this. So guys, since all the options given to us here are in cm cube, we have to convert this our answer to cm cube. So guys, already we know that 1 dm cube is equal to 1000 cm cube. So guys, in order to convert 0.5 dm cube to cm cube, we're going to multiply this 0.5 dm cube by 1000. So guys, if you multiply this by 1000, we'll have 500 cm cube. So guys, that's the answer to this question. And from here, that's option A, guys. Option A is the answer to this question. So guys, you're simply going to wipe this off, and then we'll consider the next question, guys. That's question number 8. So the question says the volume occupied by 1.58 grams of a gas at standard temperature and pressure is 500 cm cube. What is the relative molecular mass of the gas? So let's also note that the gas molar volume at standard temperature and pressure is 22.4 dm cube. So guys, let's simply zoom into our workspace here, and then let's solve this out together. So first of all, we need to recall that 1 mole of a substance which contains the molar mass of the substance will have the gas molar volume, and that's 22.4 dm cube. But guys, here we have 1.58 grams of this substance at standard temperature and pressure to have a volume of 500 cm cube, and 500 cm cube is the same as 0.5 dm cube, as we already know. So guys, our major concern here now will be what's the mass that will give us 22.4 dm cube, which is the molar volume. So we'll call this x, and then we'll go ahead and multiply, cross this out. So x will be 1.58 times 22.4 over 0.5. So 1.58 times 22.4 over 0.5. So guys, that's 70.78, and this is approximately 71 grams. So guys, that's the answer to this question, and here that's option A, guys. Option A is the answer to this question. That's 71 grams. So this would be 71 grams per mole. So that's it for this question. Let's go ahead and wipe this, and then guys, let's consider the next question. That's question number 9. It says, what is the percentage composition of oxygen in potassium dichromate 7? So guys, we are going to solve this together. So let's simply zoom into our workspace here. So we are given the molar mass of this potassium dichromate 7, and then we're also given the atomic mass of oxygen, of potassium, and of chromium. So guys, it's very simple for us to work this out here since we are given all these parameters already. So the only thing we have to do here is oxygen here over the whole compound, that's potassium dichromate 7. So times 100 since it's in form of percentage. So guys, let's go ahead and solve for this. Oxygen times 7, oxygen is 16, so we're going to do 16 times 7, that's 112. So 112 over, we're given the molecular mass of this potassium dichromate 7. So the molecular mass given to us from the question is 294. So this would be multiplied by 100. So if we go ahead and multiply this by 100 and then divide it by 294, you're going to have 38.095. So guys, this will be the answer to this question, and that's 38.09%. So guys, that's option C here, and that's the answer to this question. So guys, we're going to simply wipe this off, and then we're going to consider the next question. Guys, that's question number 10 here. The question says the volume of 2.5 moles of oxygen at standard temperature and pressure is, this is a very simple one, so we are going to solve it together. 2.5 moles of oxygen. To get the volume of 2.5 moles of oxygen, we need to understand that 1 mole of this gas, which is oxygen, has 22.4 dm cube. So 2.5 moles will now have what? And that's x here. So cross this, and then x is going to be 2.5 times 22.4 over 1. So guys, this will give us 2.5 times 22.4, that's 56. So guys, x is equal to 56 dm cube. And that's the volume here. So guys, that's the answer to this question. We're going to wipe this off, and then we'll consider the next question, guys. That's question number 11. The question here says, which test is used to detect the presence of hydrogen gas? A, the pop test. B, the glowing splint test. C, the flame test. D, the lime water test. So guys, the answer to this question is option A, and that's the pop test. So we are simply going to check out the next question. Question number 12. It says 1 mole of a hydrocarbon contains 36 grams of carbon, and its vapor density is 20. The structure of the hydrocarbon is, so guys, we are going to just simply go ahead and zoom into our workspace here, and then we're going to solve together. So from the question, we are given the vapor density to be 20. So this is VD. So VD is given to be 20. So it means since relative molecular mass is 2 times VD, so the RMM automatically is going to be 40. So now that we've gotten this, so the question, we have to understand that the question talks about a hydrocarbon. So it means that it's an organic compound which contains carbon and hydrogen only. So with this, we have that 40 grams is the mass of both carbon and hydrogen. So this 40 grams is both carbon and hydrogen. But then guys, we are already given from the question that carbon contains 36 grams. So this 40 grams is actually 36 plus H. So in that case, H is going to be 40 minus 36, and that's 4 grams. So guys, for this now, 4 grams of hydrogen will actually contain 4H, since hydrogen is 1. So if I divide this by 1, I'll still have 4. So this hydrocarbon will contain 4 hydrogen atoms. Whereas for carbon, since we have 36 grams of carbon here, if I divide 36 grams of carbon by 12, I'll have 36 over 12, and that's 3. So this compound will also contain 3 carbon atoms. So out of the options we have here, the one that contains 3C and 4H will be the answer to this question. So guys, out of all these options here, option C is the correct answer to this question. So that is it for that question. We're going to simply wipe this, and then we'll consider the next question here. So that's question number 13. It says a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. If the molar mass of the compound is 180, find the molecular formula. So guys, already we've answered this question before now, and that's option B here, C6H12O6. So let's quickly go ahead and check out the next question. That's question number 14. So guys, question number 14 says an organic compound contains 60% carbon, 13.3% hydrogen, and 26.7% oxygen. Calculate the empirical formula. So guys, for this, let's quickly zoom into our workspace here. We are going to make a table here in order to easily calculate for this. So we'll call this carbon, we'll call this hydrogen, and we'll call this oxygen. So remember, we have to do reacting mass, then molar mass, then reacting mass over molar mass, then we'll divide by the smallest ratio. So guys, these are the steps we have to take in order for us to successfully calculate for the empirical formula. So having this, the reacting mass here for carbon, we have 60% carbon, so that's 60 here. We have 13.3% hydrogen, so that's 13.3% here, and then 26.7% oxygen, 26.7 here. So guys, for the molar mass of carbon is 12, that of hydrogen is 1, that of oxygen is 16. So let's go ahead and calculate for this. 60 over 12 is going to be 5 here, and then 13 over 1, 13.3 over 1 is still 13.3. So guys, 26.7 over 16 is 1.66. So that's approximately 1.7 here. So we are going to divide by the smallest value here, and that's 1.7. So guys, here 5 over 1.7 will be 2.94. So this 2.94, and we'll approximate, and that's 3 here. So guys, 13.3 over 1.7 here will be 7.82. So that is approximately 8 here. And then 1.7 over 1.7 is 1. So guys, this will give us C3, H8, and O. So guys, that's the empirical formula for this, and that's option D here. So let's go ahead and wipe this, and then let's consider the next question. So guys, the next question here is question number 15. It says, what is Avogadro's constant, also known as Avogadro's number? So we have options A, 8.314 joule per mole Kelvin. So guys, this is not the answer to this question. 6.022 times 10 to the power of 23 molecules per mole. So guys, that's the answer to this question. The option B here is the answer to this question. That's the Avogadro's number. Guys, I encourage you to try to always remember this number because it's very important in your chemistry. So always remember this Avogadro's number, 6.022 times 10 to the power of 23. So guys, let's consider the next question. Question number 16. It says, what is the value of X in this compound if the molecular mass is 392 gram per mole? So guys, in order for us to get the value of X, we know that if we sum up everything here, it's going to give us 392 gram per mole. So all we are simply going to do here is we're going to add up everything here and then equate it to the molar mass of this compound. So we're going to have iron is given to us as 56. So 56 plus nitrogen is 14 here. That's 14 plus hydrogen is 1, then times 4, and that's 4. So these two together are multiplied by 2. We're going to also add sulfur, and sulfur is 32. Then we'll add oxygen times 4. Oxygen is 16, and 16 times 4 is 64. So this here is also times 2, is multiplied by 2. So, and then this plus X times, so water is H2 is 2, then plus 16 is 18. So water is 18 here. So all this is equal to 392. So guys, here we're going to add 56 plus 14 plus 4 is 18. Then 18 times 2, 18 times 2 is 36. So 36 plus 32 plus 64 is 32 plus 64 is 96. Then 96 times 2 is 192. 18 times 8 is 18x. So this will be equal to 392. so which is the molar mass. So guys, at this point you can add 56, 36 and 192. So 56 plus 36 plus 192 will give us 284. So 284 plus 18x is equal to 392. So guys, 18x will now be equal to, this moves over here. I'll have 392 minus 284. So guys, 392 minus 284, that will give us 108. So 18x is 108. 18x is equal to 108. So let's go ahead and wipe this top part so we can finish up this over here. So now that we've gotten to this point, we want to divide by the coefficient of x here, which is 18. So we're going to have that x is equal to 108 over 18. So 108 over 18 will be 6. So x is equal to 6. And that's option C here, guys. That's the answer to this question. X is equal to 6. So let's wipe this off and then let's consider the next question, guys. That's question number 17. It says a compound contains 40% carbon, 6.7% hydrogen and 53.3% oxygen. If the molecular mass of the compound is 180, the molecular formula is. So guys, this is the third time we are seeing this question, and that should tell you that this question is very important. You shouldn't joke with this question. You should always recall and remember how you can go ahead and solve this question and also get the answer. So guys, the answer to this question over here is option D, and that's 6 is H12 and OC. So we've answered this question before. So let's consider the next question. Question number 18. It says a hydrocarbon X with a molecular mass of 26 contains 92.3% carbon. What is the molecular formula? So guys, a hydrocarbon, like we know, will contain only hydrogen and carbon. So let's go ahead and zoom into our workspace here to solve for this. Now, once you want to find the molecular formula, we have to go ahead and find the empirical formula first. So guys, since it's a hydrocarbon, it will contain carbon and hydrogen. So guys, if it contains carbon and hydrogen only, having that carbon is made up of 92.3% here, that's 92.3. So out of, remember that percent is 100, so out of 100 we have 92.3 for carbon. If we subtract 92.3 from 100, guys, we are going to have 7.7. So this will be the reacting mass. So always remember that you have to state your reacting mass, your molar mass, so you do reacting mass over molar mass, and then finally we divide by the smallest value. So guys, now at this point we've taken the reacting mass. So the molar mass of carbon is 12, like we know, and that of hydrogen is 1. So when we now do reacting mass over molar mass, so 92.3 over 12, so let's do that. 92.3 over 12, that will give us 7.69, and that's 7.7 approximately here. So guys, when we divide 7.7 by 1, we also have 7.7. So over here we can now divide by the smallest value. So guys, when we divide by the smallest value, both of them have the same value actually, so we'll just have 1 1 as the ratio here. So this means that the empirical formula of this compound will just be CH. So guys, having this, we'll know that the empirical formula times N here will give us 26, which is the mass here given to us here. So if that's the case, C is 12 and H is 1, so that makes 13 here. So it means 13N is equal to 26. So in that case, N will be 26 over 13. So let's go ahead and wipe the top portions of this. So we're going to wipe this area and then finish up the calculation here. So if N is 26 over 13, so 26 over 13 is 2. So which means we're going to have CH to 2 here. So which means it's going to be C2H2. So this will be the molecular formula of this compound, and that's option C here, guys. So that's the answer to this question, option C. So let's quickly go ahead and wipe this, and then let's consider the next question, guys. That's question number 19. So the question here says 0.0075 mole of calcium trioxocarbonate 5 is added to 0.015 mole of a solution of hydrochloric acid. The volume of gas evolved at standard temperature and pressure is. So guys, for this we need to write an equation of the reaction. So let's zoom into our workspace here. So we are going to have, first of all, calcium trioxocarbonate 5 here, calcium trioxocarbonate 5 to react with hydrochloric acid here, and then this reaction will form calcium chloride plus water plus carbon dioxide. So guys, with this we know that we have 1 mole of this, and then we'll have 2 moles of this. We have 1 mole of this, 1 mole of this, 1 mole of this. So guys, having stated this, we know that 1 mole of this requires 2 moles of this. So in that case, since we have 0.0075 moles here, this over here, HCl, will be 0.0075 moles times 2, and that's 0.015. okay, that's 0.015, and guys, all these other ones will be 0.0075, 0.0075, 0.0075. So guys, that's the distribution of the number of moles here. So guys, this will make it easier for us here. So we are looking for the volume of gas evolved here. So guys, in order to get the volume of gas evolved here, the gas here will be the carbon dioxide, and guys, the carbon dioxide here is having 1 mole here, which corresponds to the 0.0075 mole with respect to the reaction. So guys, since 1 mole of a gas contains 22.4 dm cube, that's the molar volume of a gas, then 0.0075 moles, guys, will contain what? So let's call that x here, and then we'll cross this. So x will now be 22.4 times 0.0075 over 1. So let's go ahead and calculate this. This is 22.4 and then multiply by 0.0075. So this will give us 0.168. So x is equal to 0.168 dm cubed. So guys, that's the answer to this question. And guys, since the options given to us here are in cm cube, already we know how we can resolve this. We know that 1 dm cube is 1000 cm cube. So what we are simply going to do here is to go ahead and multiply this by 1000. So we have 0.168 times 1000, and that's times 1000. That's 168 cm cube. So guys, this is option D here, and that's the answer to this question. So guys, let's go ahead and consider the next question, and that's the last question for this JAMB repeated questions. So let's go ahead and check out this question. That's question number 20. It says, how many moles are there in 30 grams of calcium trioxocarbonate 4? So let's go ahead and zoom into our workspace here, guys, and let's solve this together. So in calcium trioxocarbonate 4, we want to know how many grams we have in calcium trioxocarbonate 4. So first of all, let's consider the molar mass of calcium trioxocarbonate 4. So calcium is 40, carbon is 12, oxygen is 16. So in this case, 16 times 3. So we're going to add up 40 plus 12 plus 16 times 3 is 48. So 52 plus 48, that will give us 100. So calcium trioxocarbonate 4 is 100 grams per mole. That's the molar mass of calcium trioxocarbonate 4. So remember, since we have 100 grams per mole, it means that 100 grams of this substance has 1 mole, or 1 mole of this substance contains 100 grams. So we want to know how many moles we have in 30 grams. So guys, this 30 grams correspond to this part. So you're going to write 30 grams since it will have the same unit with it. So we have 30 grams here. So 30 grams will give us x here. We'll cross and multiply here. So we have x to be, this is 30 times 1 over 100. So this will give us 0.3. So this is 0.3 moles. So guys, that's option D here, and that's the answer to this question. So let's go ahead and wipe this. So guys, that's the end of this video. This is where we'll end this video for today. If you enjoyed this video, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So guys, we encourage you guys to join our YouTube channel community, where we'll give you premium information on JAMB that will help you in your preparation as you prepare for this JAMB examination. So guys, thank you for watching this video, and see you next time.